Welcome back, everyone. Today we're going to talk about factoring. Specifically, what happens if you factor a product rule derivative with a chain rule inside it. Those words mean nothing to you in honors math analysis. That's right. This is really a technique we'll use next year in calculus. But it's good for you to learn the procedure this year. It goes along with factoring, so I'm going to put it in here. This process that I'm about to teach you helps you clean up the answer to a difficult problem. It's just GCF factoring, greatest common factor, but it's on a much larger scale. So what are our steps for factoring? Find the addition sign. That splits it into two different expressions into two different parts. Identify the binomial. Okay? The binomials are the things in parentheses. There will be two different ones, each with a set of parentheses on each side. Underline them or highlight them in different colors if it helps. Identify the smallest power of each binomial. That's what we're going to factor out because it's the greatest common factor. Here's a huge hint. One of the remaining terms will cancel, the other will be left with only a power of 1. And in calculus you'll understand why. Clean up what's left and see if it has a GCF. Never leave a fraction inside that. And then rewrite your expression as one term. So we're going to do two examples of this because once you get the process, it's the same thing over and over. It's very procedural. Okay? One is going to be easy with not crazy numbers. And the other one is going to be fractions and negative powers and things like that. So let's start with the easy one. Yes, this is the easy one. Factor this. Well, it said find the plus sign. Well, here's the plus sign. It's what splits the problem into two parts. Find the binomials and highlight them. Okay? One binomial is x minus 4. Another binomial is 2x plus 1. These are what I'm going to factor out. So I'm going to factor out an x minus 4 and a 2x plus 1. Always pull out the smallest power. The smallest power here is a third for the x minus 4 and a 2 for the 2x plus 1. Now let's see what's left. I pulled out 3 of these. And remember, there's always only going to be one power left. I still have the number 3. None of these are still left. There was only 2 of them because it was squared. All two of them have been pulled out. So this binomial is gone on this side, and I still have the number 2. Plus, I pulled out 2 of the 2x plus 1s. There were 3 total, which means there must be exactly 1 left. Remember, there's only one power left each time. I still have the number 4. The x minus 4 to the third has already been pulled out, all of it, so there's none of that left. And then the number 1, which really isn't important. Notice something. When you pull out both binomials, you'll have one of each binomial left, and it'll be to the first power. Knowing that makes a more difficult problem easier. Now let's clean up the inside. Let's multiply all of this together. Well, this is 6. Distributed in will get you 6x minus 24. Plus, this is 4. Distributed in will get you 8x plus 4. Cleaning that up a little bit will get you, oh, by the way, I should rewrite this, but I'm going to be lazy. Just remember it's out there. 14x minus 20. I still have my x minus 4 to the third, my 2x plus 1 to the second. But you're not quite done. Look at what's left. 14x minus 20. It has a GCF of 2. If you pull a 2 out, you end up with a 7x minus 10. And that is completely factored. So that one's not terrible. The order that I write it doesn't matter. There's no negative exponents, so they don't have anything that goes on bottom. There's no fractions anywhere in that problem inside the binomials. Now that we've seen an easier problem, let's try a more difficult problem. Okay? Step 1, find the plus sign. It splits the problem in half. Find the binomials. One binomial is 3x minus 2. The other binomial, 4x minus 5. So I'm going to pull out the 3x plus 2 and the 4x minus 5. But which power? Well, I have a 1/3 power and a negative 2/3 power. You always pull out the smaller power, and negative 2/3 is smaller than positive 1/3. I have a negative 3/2 and a negative 1/2. I always pull out the smallest power. Well, negative 3/2 is the smallest power. It's smaller than negative 1/2. Now let's see what's left. I had a 1/3 power of this, and I pulled out a negative 2/3. How far is it between 1/3 and negative 2/3? Oh, it's 1. Remember, you only ever have a power of 1 left on the inside. I still have the negative 1/2. I don't have this binomial anymore because it's entirely factored out. And I still have the number 4. Plus, on this side, the 4x minus 5 to the negative 1/2, I pulled out a negative 3/2 out of a negative 1/2. How far apart are those powers? Oh, that's right. There's still 1 left. There's always 1 left. I still have a 1/3. This was factored completely out, and I still have a 3. So let's clean up the inside. The outside will stay the same, so let's just focus on the inside. If you do these two things, you get a negative 2, distribute in, negative 6x minus 4. Thankfully, these things cancel each other out, which is very fortunate. And I still have a plus 4x minus 5. X plus 2 to the negative 2/3. 4x minus 5 to the negative 3/2. Clean up your inside. You get a negative 2x minus 9. If I want to make that look a little bit better, I'm going to pull out the negative. And I'll make it a positive 2x plus 9. Now these are still with the problem, but they're both negative powers. So where do the negative powers go? They go on bottom. And there you go. No more. I have no fractions inside of my binomials. They're all integers inside the binomials. I have no negative powers, and I have nothing else I can pull out. I have factored that completely. If you want to see more practice like this, check out the calculus page. Go down to where you can find the video on chain rule factoring for calculus. In that video, I show the calculus steps, and then I show this factoring. The factoring there is a little bit tougher, but it's the same process. Ignore the calculus at the beginning, and then focus on the factoring if you want more practice.